Number 1 gives us quadrilateral A prime, B prime, C prime, E prime. So this inner quadrilateral here as the dilation of the outer quadrilateral. And then we're going to answer some questions about it. So this first one wants us to determine the scale factor. And when we're determining the scale factor, we want to remember that we take a look at a new measurement divided by an original measurement. And we want to make sure that we're comparing corresponding parts. So we can take a look here. We see that we're given side C prime, E prime, but not CE. So we won't be able to use that. But we are given B prime, C prime, and also BC. So then we can take and do the new or the prime measurement, which is 3 over the original measurement 6, and we get our scale factor as 1/2. Part B then asks us to find the length of A prime, B prime. And so A prime, B prime is here. So now we're going to use our scale factor with the corresponding part. And so our new part will equal the scale factor times our original part. And so the scale factor is 1/2, and we'll multiply that by the original length, which is 3. And that will give us a fraction of 3/2 or a decimal of 1.5. So whichever one you would like to use there. Next one asks us for the length of side CE. And so now we're going to be doing this scale factor backwards since we're looking for the original length. And so you can kind of write it out with this equation if you want. But now we know the new length. Okay, so we know that the new length is 2.5. And we're looking for that original. So we've got 2.5 equals the scale factor of 1/2 times our original shape. So we'll be dividing by 1/2 essentially. So we'll be taking 2.5 divided by 1/2, and that is 5. So that's going to be our CE side length. And so when you think about 1/2, okay, that's kind of like dividing by 2. So then when we go to the outer part, so when we go backwards, we'll actually be multiplying by 2. So this bigger shape is 2 times larger than the original. All right, then what is the measure of angle A? And so angle A is here. Angles stay the same in a dilation. So angle A is going to equal angle A prime. And we see that A prime is 114 degrees. So angle A is also going to be 114 degrees. Number 2, match each set of similar figures with the corresponding scale factor. And so I like to go through and kind of look at, is it getting bigger or smaller to start with, so that I know whether I'm going to be looking at the scale factor larger than 1 or smaller than 1. So look for your primes. So here's the new one. So we're going from here to here, and that's getting bigger. And then compare these getting smaller. And then compare these corresponding parts. So we went 8 to 4, okay, getting smaller. That's dividing by 2, which is the same as multiplying by 1/2. So this is figure number 1. Next one, when we look to the primes, so here's the original, here's the new, that's getting smaller. So this one's going to be a fraction again, less than 1. So we can automatically kind of tell that this is going to be part C, but then you can compare your corresponding parts as well. So we see this 4 versus 12. So we divided by 3, which is multiplying by 1/3. You can also simplify the fraction of the new over the original, 4 over 12, which simplifies to the 1/3. Next one, so here's our original ABC, and it's going to this one, which is getting larger. So our new measurement is 9. Our original measurement is 3. That's 3 times bigger. So 9 divided by 3 is 3. So part D is figure 3. And then the final one, when we go from this original to this one, is getting bigger again. Find a corresponding part. So we've got BC and B prime C prime. So B prime C prime is 2 times bigger. So if we did 12 divided by 6, we'd get that scale factor of 2. Number 3, given that segment A prime B prime, so this segment is parallel to this segment, answer the following questions. And we saw those little arrows on there for parallel as well. So what is the length of segment AB? So now we need to look for the scale factor in order to figure this out. So we've got these 2 triangles in here. So let me highlight the 2 triangles that we're seeing. So we've got this larger triangle ABC, then we've also got this smaller triangle A prime, B prime, C prime. So if we take a look at how much smaller this blue one is by finding the scale factor, so if I just compare the new side A prime C versus the original side AC, so A prime C is 6, AC is 9. So our scale factor here is 2/3. So if we're going from the larger shape to the smaller shape, we'll be multiplying by 2/3. Okay, if we're going from the smaller to the larger, we would be multiplying by the reciprocal or the flip of this. You can also think of that as dividing. So if we're taking for segment AB, so we're looking for this orange one, that one goes with A prime, B prime, we're really taking 5 and multiplying by the reciprocal of the scale factor. Okay, because then now this is larger than 1, so this is like multiplying by 1.5 to get to this one. So then we're going to get 15 over 2 or 7.5. Then what is the length of B prime? So now we just want this little piece. So this is just a chunk of one of the triangle sides, not the whole thing. And so in this case, we know that the sides are being split proportionally. So this side compared to this one is going to be the same factor as this side compared to this one. So if we look here, when we go from 6 to 3, we divide by 2. So we're going to do the same thing to this 7. So it's going to be 7 divided by 2, or 3.5 for that segment. And then in these dilations, the angles stay the same measure. So what's the measure of angle A? It's going to be the same as this A prime. And then we see these 2 angles in that blue triangle. So we can subtract those from 180. So we can do 180 minus 75, which is 105. And then we can subtract 45 from that and get 60 degrees for angle A. Number 4, explain how we know that segment DE is not parallel to BC. So remember, if they are parallel, they will split the sides proportionally. So this divided by this will equal this side divided by this side. So if we take 4 over 2, that should equal 9 over 5, and it doesn't, because this is 2, and 9 divided by 5 is 1.8. So we know it's not parallel because the sides are not proportional. All right, then let's take a look at number 5. So number 5 says, given the triangle below, determine the following. So the first thing that we need to do is determine which of the 2 triangles above are similar and cross off the one that isn't. So when I'm looking at this, one thing that I'm noticing is in these first 2 triangles, they both have legs of 5 and 12. So that means one of these is not going to be similar to the other, since the only measurement that changes in these is that hypotenuse. So let's see which of these two is not similar to this larger one. So we notice that we multiply the 5 by 2 to get 10 and the 12 by 2 to get 24. So then 14 times 2 would be 28, and 13 times 2 is 26. So this triangle here is not similar to the others. So we're just going to cross that one off. Now in part B, it says to label one of the triangles A, B, C. So I'm going to label this first one. Then it says to label the next one A prime, B prime, C prime. Now it asks us to write a sequence of rigid motions that will bring one to the next, rigid motions and dilations. And this could change depending on what you want to write. So yours doesn't have to be exactly equal to my explanation, but I like to start by translating the first triangle. So I'm going to translate triangle ABC by directed line segment A prime, so that I get these two vertices matching up. Then I like to rotate it if I need to, so that it's lined up exactly. Now, these aren't the same size, so I'm going to say, if necessary, rotate ABC around A prime until B lands on side A prime, B prime. Okay, because we know it's not going to land on B yet, because this length is only 5 and this one's 10, but I want to rotate until it lands on the side. Okay, then I'm gonna dilate triangle ABC using A prime as the center of dilation and a scale factor of 2, since I need to make it 2 times bigger. So that's going to pull B onto B prime, and then I've got them on top of each other. Number 6, given a right triangle with an altitude drawn to the hypotenuse, determine which of the two triangles are similar to A, B, C. So when I'm looking at this, so when they did A, B, C, they went on the hypotenuse and then they went to the short leg. So as I name the other triangles, that's what I'm going to be looking at, is to go from the hypotenuse to the shorter leg. So when I'm looking at this little triangle over here, I want to go hypotenuse to short leg. So this is going to be A, C, D. And then I'm going to do a similar thing to the other little triangle in there. So I want to be going on the hypotenuse to this shorter leg. So I'm going to have to start at C and then go B, D. So there are my similar triangles. Now it wants us to find the length of BD. So we're looking for this here. So remember, we can set up a proportion that takes this kind of green hypotenuse piece over the altitude equals the altitude over the other piece. So for this, we can go 8 over 6 equals 6 over x, and then cross multiply. So we'll do x times 8, which gives us 8x, and then 6 times 6, which gives us 36. Then you can divide both sides by 8, and we'll get x, which is BD. Okay, so then BD is equal to 36 divided by 8, which is 4.5. Now it wants us to find the length of AC, which is this segment here. So this blue segment, which is the hypotenuse of this right triangle here. So we'll be able to do AC squared is equal to 8 squared plus 6 squared. So this is 64 plus 36, which is 100. So AC squared equals 100. So then we'll square root both sides, and we end up with AC equaling 10. Number 7, determine if each of the following sets of triangles are similar. If they are, then state the similarity, fill in the similarity statement and what your method for proving them similar were. So on this one, just be careful here that you don't say that angle C is 123 by vertical angles, because this isn't a straight line, okay? It bends right here. So these are not vertical angles. So make sure that you do triangle sum theorem here to figure out this missing angle. So we'll do 180 minus 123, which is 57. And then we'll subtract 36, and we get 21 degrees for this angle E. Then we see that angle E is the same as angle B, and angle A is the same as angle D. So these two triangles are similar, okay, by angle similarity. They have two angles the same. Then we just need to do the similarity statement. So what angle went, so A, B, C, we want to go in the same order. So what angle went with A in this top triangle was D. What went with B was E, and then C. Next triangle, or next set of triangles, so we see that we've got an 83-degree angle here, but we don't have any angles in this one. And we also have all three sets of sides marked or given to us. So we want to compare these. So what I like to do is take the sides in one triangle and just write them in numerical order. So 12, 14, 17. Then I'm going to divide by the sides in the other triangle in numerical order too, because the shortest side would have to go with the shortest side, middle with middle, long with long. So shortest side over here is 24, medium size is 28, and the large size is 34. And each of these divide down to a decimal of 0.5. So then that means that these triangles are similar. And this is by side similarity, since all the sides are proportional. So then we'll write out the similarity statement here. And so this one went PQR. So this one went the shortest side to the longest side. So PQR. So we want to go the shortest side to the longest side. So this is going to be STU. And then the last one gives us all the angles in one triangle and all the sides. And then in the other one, it only gives us one angle and then two sides. So this one, we're going to want to be looking at the two sides that connect at or include this 60-degree angle so that we can see if it's side angle side. So we see the congruent side. So now I'm going to take the 7.5 and the 12.7. And again, I just did smallest and largest. So then over here, I'm going to take the 15 and then the 25.4. So then just divide those. And when you divide those, 7.5 over 15 is going to be 0.5. I'll just write that up here. And then 12.7 divided by 25.4 is also 0.5. So these are similar also, and this time it's by side, angle, side. We knew the angle between the two sides were congruent, and then these two sides were proportional. Then we just need to write the statement. So this one went A, B, C. So it went up the short side, okay, to the middle side, and then the largest side. So we need to start at D and then go along the short side to F, and then finally at E. So DFE for that one. Number 8, given the following similar triangles, determine the length of segment FD. So in both cases, we are looking for the length of FD. So I'm just going to highlight it in both pictures. And so in this one, and it told us we have similar triangles. Okay, so we know that they're similar, so we'll be able to set up proportions. So for this side specifically, this side goes with the 68 and the 44 degree angle. So I can say DF divided by 12 is going to equal 27 divided by 9. So you could set up a proportion that way. You could also recognize that this segment and this segment are the corresponding segments, and 27 is just 9 times 3. So then we're just going to be doing 12 times 3 to get this side, which is 36. And you're going to get the same thing if you cross multiply here. In this next one, so we don't have the corresponding side here, okay? And we don't have two sides in this right triangle. So we're going to have to do kind of two things in this one. So we're going to have to do Pythagorean theorem to figure out how big AC is. And maybe you've done enough of these that you know it's going to end up being 5. If you don't, then you would just be doing 3 squared plus 4 squared equals that side squared. So you get 9 and 16, which is 25, and then you square root it to get that 5. So now we'll be able to come up with this side length here. So this corresponds here. This one corresponds here. And so we'll be able to set up a proportion. So we can say DF over 5. So this side over 5 equals 6 over 4. And then you could cross multiply here and get that DF equals 5 times 6 divided by 4. So 5 times 6 is 30, divided by 4 is 7.5. You also could do the scale factor here. So if you're trying to figure out what you multiply here, it's 6 divided by 4, which is 1.5. So then we'll take 5 and multiply by the scale factor of 1.5 to get 7.5 that way as well. All right, last two problems have us dilating shapes by a scale factor. So this one's going to have us dilate by a scale factor of 2.5. So first thing I'm going to do is draw in my dilation lines. So that is just a straight line that goes from the center of dilation through the points, because this is where you're going to measure along to figure out your dilation. Now, my ruler is not going to be the same as yours since this is on the screen and I can change the size of this, so it's not set. So you're going to follow the similar process, okay, on yours, just won't be the exact same numbers. So what you're going to do is you're going to set your 0, okay, or your ruler on P, the center of dilation. Then you're going to measure how far it is from P to C. Okay, and in my case, P to C is equal to 3. So then I'm going to multiply this by the scale factor, which is 2.5. So 3 times 2.5 will be the measurement of my new segment. And 3 times 2.5 gives me P to C prime as 7.5 centimeters. So then I'm going to measure out to 7.5 centimeters, and that's where C prime is going to be. So then I'm going to do this again, and I'm going to measure to B. So from P to B looks to be about 7.2 centimeters on my ruler. So then I'm going to multiply this by the scale factor of 2.5. So 7.2 times 2.5 is 18. So P to B prime is going to be 18 centimeters. So then I'm going to need to measure out to 18 on my ruler. And that's where B prime is going to be. Then we're going to turn over to A. Let me make this shorter. Then we're going to go over to A and make sure that you keep your 0 on here. All right, so then to A is 4.2. So P to A is about 4.2. Then I'm going to multiply by the scale factor of 2.5. and that gives us 10.5 for where A prime is going to be. So then we'll measure out to 10.5 along that line and draw our A prime. Then you're just going to connect these, and whoops, let me get a thicker line here. So then your new shape is going to be the connection of all of these points, and it should have all the lines parallel to the original lines, and should be 2.5 times bigger. And then just make sure that you label these as C prime, B prime, and A prime. All right, then number 10 has the center of rotation inside of our quadrilateral, and we have a scale factor of 1/2. So this dilation is going to get smaller, and it's going to be fully contained inside of this quadrilateral. So let's go ahead and draw in our dilation lines first. So connect P to each point, and then this is where we're going to be measuring. And you don't actually have to go beyond this because we know it's going to be inside of this quadrilateral. So even if you just did this, that would be fine because it's going to get smaller. So our new points are not going to be outside of the quadrilateral. So then go ahead, set your ruler on P, and then measure out to one of the points, whatever one you want to do first. So this one is PC is equal to 5.2. So then when I go and find C prime, I'm just going to multiply 5.2 by 1/2. And so then this is going to be 2.6. So then I'll measure out to 2.6. There's C prime. Okay, go to the next one. So P to D appears to be 5.2 as well. Okay, so P to D is 5.2. So P to D prime is going to be 2.6 again. Okay, then rotate to A. So P to A is 2. So PA is 2. So PA prime is going to be 1. So then measure out to 1. And then finally, P to B is about 2.4. So PA looks like 2.4. So PA prime is going to be 1.2. And then you can just connect all of those. And then again, each of those sides should be parallel to their original side, and then that shape should be half the size. And then just make sure that you label those. And then you're done.